Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam online classes on the topic light energy. So light is something which gives energy, and this light energy can be converted into other forms of energy also. And before we come to today's lesson, let us just see what we have studied in the previous classes. The first one is about properties of light, that is reflection. Reflection of light is done by what is called as mirrors, is it not? So these are the two types of mirrors. Here you see the back side is coated, is it not? And we have discussed in detail the difference between the two and the property of light. Okay, these are the mirrors. This is called as in a driver's side. By the side of the driver, we keep this convex mirror. What does it do? It gives the reflection of the vehicles coming from long distances. And I need not tell about the plane mirror, what you are using in your home. Every day before coming to class or going to any shop or any places, you dress your hair, no? And we put some powder, this, that, you put some tilakam or something like that. All this we use what is called as plane mirror. And this mirror has laws of reflection. So concave mirror, convex mirror, plane mirror. And also we discussed about the image formation. And where do you get images? We get in the screen, is it not? So Baba says for every action there will be reaction, as Newton's third law. For every action there is an equal and opposite reaction. For every object there will be reflection. You have heard so many stories about reflection, is it not? So when you go to a pond, when the water is still, we can see our reflection in the water. So because we consider it to be a plane mirror. Similarly, we have seen the properties and uses of concave mirror and convex mirror, is it not? And also the kind of images formed there. And mirror formula 1 by V plus 1 by U is equal to 1 by F. That is called as mirror formula. What is V? V is image distance. What is U? U is called object distance. What is F? F is called focal length. And also we have seen in the previous class, magnification is given by the ratio of image distance to the object distance, is it not? Or you can also write it as size of the image by size of the object. So that also comes to magnification. We say some images are big, some images are small, we say. Or big or small is used by the word magnification. Also we discussed about uses of mirrors, is it not? that is used by concave mirror is used by dentist to see the enlarged image of the dental structure, any defect in the dental things. And also we have seen they are used in operation theatres, in vehicles and so on. Convex mirror of course is used in vehicles to see the small image of the vehicles coming from behind. And also we have seen about refraction of light. That is a change in the direction of the light. And that happens because of the change in the change in the wavelength. So refraction of light and loss of refraction. So this happens when the ray of light passes from one medium. There are two kinds of medium. One is called rarer medium, another is called denser medium. So when a ray of light passes from rarer to denser, it moves towards the normal. When it moves from denser to rarer, it moves away from the normal. So what is the loss of refraction? First one says the incident ray, the refracted ray and the emergent ray all lie on the same plane, and the normal also. And the second law is refractive index is defined as the sine of the angle of incidence, the sine of the angle of refraction, sin I by sin r. Sometimes they call it as mu also. Sometimes they use the symbol n. The second law, sine of the angle of incidence to sine of the angle of refraction. And the experiment we did was by the glass slab. This is called glass slab. You can also purchase one slab, even mirrors also, and try this experiment. Okay, this is what he said on the day. Taking a drawing sheet, keep it in the middle of that and put a boundary and fix up pins, and one as incident ray, and put two more pins as a refracted ray. Is it not? Or you can say emergent ray. Then we find the deviation there. And you have to measure the angles, namely angle of incidence and angle of refraction. So you must take the sine of that angles. We get what is called as refractive index. So that was a very famous glass slab experiment. And also we have seen refraction through spherical surfaces. When you say spherical surfaces, there are two types. One is called concave, another is called convex. Concave and convex. So this happens in the case of what are called as lenses. What is a lens? Lens is a transparent medium. And what do you mean by transparent medium? So this is a lens. Here the middle portion is thin. The outside portion is thick. That's why it is called as concave lens. And this is called as convex lens. The middle portion is thick and the surrounding places are thin. And the most common thing what we get is called as, see, in your language you call it as booth kannadi in Kannada. So this is an example for double convex lens. Here middle portion is thick, and so you can see how much thick the finger looks at. You can try yourself. Even also I have told one more interesting thing, that you keep in the sunlight like this And if you keep a piece of paper at a proper distance called focal length, you will see that the paper gets burnt, or any other thin materials of wood or something get burnt. That is because of refraction of light. So the rays coming parallel pass through a point, and that is called as focal point. You can do this experiment on this. It's available very cheap in the market, and you can try different kinds of experiments on that. And we have seen, we defined the different definitions on that. And also, now coming to the home assignments, name the type of lens which produces virtual image always. So concave lens, concave. So middle portion is thinner, that is concave. So it always produces virtual image. What do you mean by virtual image? Virtual image means you cannot catch in the screen, and it will be always erect. Suppose this is the object, image also will be like that only. That is called virtual. Okay. In case of concave lens, there is only one position where you get the image, and that will be, the image will be virtual. Differentiate between concave lens and convex lens. And convex lens is real and inverted image is formed. So in case of convex lens will be bulged at the center. Okay. So image is real. Real means what? It will be like this, inverted. So in all the cases, we get a real image, but only in one case where the object is between O and F. If the object is between O and F, you get a virtual image, and it will be formed behind the lens, other side of the lens, and that's why it's called virtual, and it will be erect. That is only one case in case of convex lens, and it is bulged at the center and thinner at the surfaces. Concave lens always produces virtual image, and erect image is formed, and it is always smaller. Smaller means what? If the object is say 10 centimeters, the image will be 0.5 centimeters. Always smaller, and image will be virtual. It cannot be caught on the screen like this. It cannot be caught on the screen. And one more property difference is it is thinner at the middle, bulged at the surfaces. So these are some of the difference between concave lens and convex lens. Coming to next question, it is a numerical problem. I think all of you have tried it. A concave lens has a focal length of 15 centimeters. So focal length of concave lens is minus 15. When you read a problem, you must write it in the data, given data. You must write it first. At what distance should be the object from the lens be placed? So they are asking image distance. So image distance is 1 by u is equal to minus 1 by 30, and therefore u is equal to, this is what is called as u, 30, reciprocal of this. Okay. So it will be, you can make out, focal length is 15, object distance 30, means it is at 2f. Is it not? And one more thing is this magnification, V by U. V is minus 10, U is minus 30. So minus 10 by 30 becomes 1 by 3. the image is 1 by 3 times smaller than the object. So size will be very small, okay. So this is the problem on concave lens, and you have to use the lens formula. So when a problem is given, first you must write data given, and you must know what is to be found out. Use the formula, apply it. At the end, don't forget to write the answer. So this is the answer. Object distance is equal to 30 centimeters. Magnification, second answer, 1 by 3. So answer is, image is 1 by 3 times smaller than the object. That's all you have to write for the answer for this question. Now coming to today's topic, we come into dispersion of light through glass prism. So here is a very interesting thing you must note. What is glass prism? It is a transparent medium bounded by any number of surfaces in such a way that the surface on which light is incident and the surface from which light is emerges are plane and non-parallel. They are not parallel. So this is the photo of a prism. This is white light coming here. That is after refraction, it splits up into 7 colors. So a prism will be like this. This is glass prism. Here there will be 2 triangles. This triangle may be equilateral, right angled, okay, so or any other triangle, but the 2 triangles must be similar, and you have 3 rectangles here. Can you see it? There are 3 rectangles here, so it is a glass prism. It gives a very interesting thing, what is called as spectrum of light, as it is shown here in the figure. We get a beautiful set of colors, and that color set is called Vibgayar. See, this is a glass prism. This is the incident ray, namely red, white light. When it passes through a rarer medium to denser medium, this glass, is called denser medium, and this air is called rarer medium. And here there will be what is called as normal. You have to draw a line here. Normal. So when rarer to denser goes towards the normal, and it bends. That is due to refraction. And the different colors are formed because of the different refractive indices. So these colors each will have different refractive indexes. So when white light or sunlight passes through a prism, it splits up into constituent colors. This phenomenon is called dispersion of light. So when white light passes through a prism, it distributes into 7 colors. This is due to the fact that refractive index of prism is different for different colors of light. And now you must know what are the different colors, and that is called as spectrum. And again, this is air, rarer, goes away from the normal. And how do you get it? There is a small experiment or activity you can try. You can also do it. So this is a beautiful rainbows what you see in nature. Other day I asked some 5 questions about it. Have you thought about? Can you remind me what are the questions? The first question was, why the rainbow is bent like this? It should have been a straight. But why it is bent? Because the hemisphere what you see with our eyes, the space around us is hemispherical in nature. That's why whatever image is formed will be hemispherical. Okay, that's why it is bent like this. Actually, if you speak from two-dimensional point of view, it is not bent. Because we see this imaginary sphere, imaginary bowl, what you call it as celestial sphere. This is called as celestial sphere. The celestial sphere is hemispherical in shape. That is why it is bent like this, number one. Second question, why it happens only in the rainy season, but not in summer? This rainbow occurs because of the raindrops. No? The most colorful phenomenon in nature is primarily due to the dispersion of sunlight by raindrops. So here the raindrops acts as the prisms. And how much drops will be there? There will be millions of drops. So millions of prisms and millions of colors joining together like this. And sometimes you will have primary rainbow, secondary rainbow and so on. It will be little dimmer. This will be bright usually. And these are the 7 colors that is formed. Okay, one of the beautiful formation of God. God who is a creator, you must be grateful to God to give this beautiful nature. The rivers, the plants, the birds, the rainbow, the sun, the moon, the stars, whatnot, the clouds moving, the mountains, all these are different forms of nature, right? So, that is the answer to the second question. And you cannot get raindrops in the summer season because weather will be very hot. Is it not? And one more question I asked was why it happens in the morning or evening only. In the morning you can see the rainbow on the western direction. In the evening we can see the rainbow on the eastern direction. It is opposite to the direction of the sun. Why opposite? Because the incident ray should come from sun. In the morning, the sun will be at the east. So the rays from the east will fall on the water droplets. And these water droplets form the formation of colors. Is it clear? Similarly, evening time, sun will be in the west. And when they fall on the water droplets, the rainbow is seen in the eastern direction. And why the second rainbow? What about that? There the incident angle will be different. Therefore, it will be thinner. It depends on the incident angle. In the angle with which the sun's ray fall on the raindrops. Okay. So, that is the answer for that question. And one more question was why it is not straight. I answered. One more question was the rainbow colors. Name the colors. There are 7 colors there and it is called as Vibgayar. And the names will be, I am just going to tell that. Before that, you should see how you can get it in the laboratory or in your house. What you do is, that is called spectrum of colors. And the colors that are formed are Vibgayar. We start from V here. I, B, G, Y, O, R. These are the colors. V stands for violet, indigo, blue, green, yellow, orange, red. This is called spectrum. Spectrum of light. In laboratory or in home you can get from the screen, is it not? But in nature you find on this space or in the sky. So using a prism and sunlight. So for that, you take a empty cardboard box, just like your shoe box, for example. Take a box and opening is made on its cover with the knife and is closed with the transparent paper. So there must be an opening and it should be covered with a transparent paper, something like a glass paper. Then a thin slit is made. Slit means small hole like this using a knife. The opposite side of the cardboard. One side you have a rectangular opening, other side you have a slit. With a knife only you have to cut that box with a knife. Then the prism is placed on a block inside the box. So in the same line it should come. Where the slit is made, on the same line the prism is to be kept. It should be kept on the inside the box on a block, just to give the height for that. Okay. And the slit side of the box is toward the sunlight. You have to keep the slit facing the sunlight, because the sunlight rays pass through the slit and they fall on the prism, and the colors can be seen on the other side, that is screen. Okay, that's all the experiment you can try with any type of rectangular boxes, but you should do only in the case of when the sunlight is there. The sunlight is not there, you can't do that, because you must pass a ray of light. Even you can see the spectrum by using a mirror. If you keep a mirror in the line of the sunlight and make it focus on the prism, on the wall you can see the beautiful color formation, which is very easy to do it. Or you can do like this also. And the prism is placed on a block inside the box. The slit side of the box is toward the sunlight. Now we can see the colored strips on the transparent paper. The frequency of the colors in decreasing order is, this is very important. So, decreasing order of wavelength. So, first one is red. R stand for red. Okay. So, least bending is red. After that, orange comes. After that, yellow comes, green, blue, indigo, violet. To make it, learn it easily, we call it as Vibgayar, easy. So we should come the bottom. Okay. So violet, indigo, blue, green, yellow, orange, red. These are the 7 colors, and totally they are called as spectrum. Spectrum of light. How it is got? It is got due to the glass prism kept facing the sunlight. Okay. So least bending is red, most bending is violet. In between you have these colors, and each one have its own wavelength. Okay. This is the white light. This is the normal. This is incident ray, what you call. This is refracted ray, this is emergent ray, and this can be caught on the screen in a white sheet attached to a cardboard, gives a screen. So this is the prism, glass prism, and this is called angle of incidence, and this is called angle of refraction, and this is what is called as dispersion of light. So white light is made up of how many colors? 7 colors. So this is what about suppose how can you see these objects? How can you see these colors? How can you see this beautiful nature around us? It is because of a camera within us. Can name the camera within us? Yes, it is the eyes. E-Y-E, not the eye. So our human eye is a very beautiful camera with a convex lens here. So this is the convex lens. The front portion inside the convex lens is surrounded by, so there are 3 layers here. You can make out the 3 layers are sclera, choroid, retina. Retina is the innermost layer, most important. It is like a screen it acts. And this is the optic nerve which is connected to the brain. Okay. And there will be 2 kinds of liquids here. One is called as vitreous humor. Another is called as aqueous humor. So aqueous humor, vitreous humor. They are the 2 kinds of liquid that you find. And these are called, nerves or blood veins. Okay. And this is the most sensitive part, please note. And for the adjustment of this, you have what is called as iris. And this is the black, what you call pupil. So these are the main parts which you are going to study in the biology in detail about it. Okay. Now our concern is only about the convex lens here and how the image is formed. This image will fall on this. What is called as retina. Okay. And in some cases, there will not be forming any images. That is called defects of the eye. Now let us see what are the defects of the eyes. We have got mainly 4 types of defects. When an eye is not working properly, then we have to use what is called as spectacles. You might have seen even some of students also will have spectacles. Why they are using spectacles? Because the eye is not having the proper capacity to form the image. So in an eye, a convex lens forms the real inverted image and definished image at the retina. This image is sent to the brain and brain will set it right. So they is sensitive to yellow-green light having wavelength 5550 angstroms. A degree means what? It is the unit of measuring this. It is called angstrom. Angstrom. We call it as A degrees. So, wavelength 5550 angstrom. The light with the least wavelength is violet, and violet will have 4000 angstrom. And one with the most wavelength is red, 7000 angstrom. That is how the wavelength is measured. The size of an object is perceived by our eye depends on the visual angle. Visual angle means what? The angle with which we see the object. Simple. So, suppose you want to see an object, if the visual angle is theta, theta means what? It is the name of the angle. Say angle may be 30 degrees or 40 degrees or 60 degrees, etc., etc. The image I1 at retina is small, hence it will appear small. If it is brought near the eye, the visual angle theta is large, and hence the size of the image will increase. So we see some of the small objects like ants, for example. We have to see in a small way, is it not? So it all depends on the angle with which we see the object. And if the angle theta is more, the image also will be big in size. If the theta is less, image also will be smaller in size. So that angle is called as visual angle. See, this is theta. This is the object. depending on the angle formed here, we will see the image I1 and I2. Here image is seen bigger in size, here it is smaller in size. So that depends on the angle here, theta 1 and theta 2. This is what is called as objects. And here you get images. And this portion of the eye, it is called as, come on, retina. Okay. And coming to power of accommodation, means our eye cannot see all the objects. Some of the objects it can see, but not all. So there is an ability of the eye to see objects from infinity to 25 centimeters. Means what? You cannot see the object which is very near to your eye. You can try if you want. That's why you must always read or keep the books for reading or writing at a distance of 25 centimeters. That is because of power of accommodation. If the object is brought very near, you can't see. Similarly, if you kept a very far distance also, you can't see. Is it not? Suppose somebody is coming from a long distance, you cannot make out who is it. You can guess. Only when he comes near, or I have got a particular capacity. That is what is power of accommodation. So below 25 also you can't see correctly. In a long distance also you can't see. So that is called far distance and near distance. If the image of the object does not form at retina, the eye has some defects in vision. So if it does not fall on retina, then we cannot get the image. So what are the common defects of vision? So mainly we have defects called as, first one is myopia, also called short-sightedness. So here what happens in this defect, the distant objects are not clearly visible. You can see the near object but not far object. Some students will be having the defect. They always want to sit in the first bench because they can see the board correctly. And that is called as short-sightedness. But there are some students who always want to sit back. They can't see it near. That is called as hypermetropia or long-sightedness. So here what happens, distant objects are not clearly visible. They always request the teacher to sit in the first bench, very near to the board. And here what happens, the image will be formed before this. This is the retina. In front of the retina it is formed. Therefore they are not able to see the board or book or whatever is shown, they can't make out. So that defect is called as short-sightedness. Here what happens, the far point is at a distance lesser than infinity and hence the image of distant objects is formed before the retina. So this object should be lesser than infinity. That is called myopia or short-sightedness. Now what is the solution? How to make it to fall on the retina? That can be done by using a concave lens, a spectacle of concave lens. If you use a concave lens, spectacles, then we make the rays to fall on the retina. Now, how do you select that? So they have got what is called as power of a lens. And the power is measured in terms of diopters. The inverse of the focal length. F is focal length. So reciprocal of focal length is called as power. And that is measured by a unit called diopters. Diopters. You might have seen spectacles when they prescribe, the doctors prescribe, they are at 2D, 3D, 4D, etc. plus 2D. plus 3D, etc. Sometimes minus 4D, minus 1.5D, like that. D means diopters. Diopters means reciprocal of focal length. That is how the power of the lens is measured. So he must use a spectacles having concave lens in the case of myopic eyes. Okay, so that is for your information, and this is a very interesting thing because most of your friends are having this defect. And one more defect is hypermetropia. Hypermetropia, spell it correctly, that's a biological word. In physics, it is called as long-sightedness or far-sightedness, FAR. Here, what is the defect called? In this, we cannot see the near object, but he can see the far object. That means he wants to sit in the last. Because if you sit in the last, he can see clearly. He can see the far object, but not a near object. So, near point is at a distance greater than 25 centimeters. So, the image of the near object is formed behind the retina. Here defect is no, this is retina. Behind the retina it is formed. Now, what is the solution? You have to use what is called as spectacles of concave lens. Sorry, convex lens here. Convex lens, bulged at the center, thinner at the surfaces. Okay, so by using a spectacles of convex lens, the image can be made to form on the retina. So please note it. Long-sightedness, convex lens. Short-sightedness, concave lens. In Kannada we call it as Sa Ni Da Pa. Sa means metropia, myopia. You have to use a concave lens. Da means hypermetropia, duradrishti. There you have to use convex lens or converging lens. You all call it as converging lens. So, beyond this also there are some defects. For example, the elderly people, when the age comes, the eyes lose the capacity to make images, to form images. That the defect is called as presbyopia. Presbyopia. So here both near and far objects are not seen, are not visible. So far distance is lesser than infinity, near point is greater than 25 centimeters. So what you will do? This can be corrected by using two separate spectacles. One for myopia, another for hypermetropia, or by using bifocal length. You might have seen some spectacles of aged people, there will be two lenses. And these two lenses, one is convex and another is concave. Concave for myopia, convex for hypermetropia. And that is why you call it as bifocal. Bifocal means two focal lens. And the common disease among the old aged people, usually after 60, you get this defect that's called presbyopia. And last one is astigmatism. Astigmatism is also one kind of defect due to the imperfect spherical nature of eye lens. I told you that eye lens will be spherical in nature. But if it is not perfect spherical, then you get this. That is called astigmatism. Here, the focal length of the eye lens is in two orthogonal directions. In different directions. So, what is the solution for that? They cannot see objects in two orthogonal directions simultaneously. This defect is direction can be removed by using cylindrical lens. In your language, it is called soda glass. Cylindrical lens. The lens will be cylindrical because they have got a defect called astigmatism. Okay. So, these are defects of the eye. Now, we will come to the last part of the home assignments. And the first question is, Three students, Ria, Tia and Gia, are using spherical powers 2D, 4D, minus 2D. What type of defect in vision they have? So D is nothing but measuring the power of the lens. Okay. How does the focal length of the eye changes when the lens is used to correct the defect of vision in case of short-sightedness and long-sightedness? And third question, a person looking at a net of crossed wire is able to see the vertical direction more distinctly than the horizontal wires. Now, what is the defect due to? How is such defect of vision can be corrected? Okay, come prepared. Okay, thank you.